now going to create a query to pull out all these people that work under Megan Barry. So we basically want to include all the people in answers 1 and 2 above. So in the results, we want to include Megan Barry and all the employees that work for her. And to do this, we're going to start with not writing a recursive query. We're going to start writing a regular CTE query to extract all these people. And the first, we're going to have 3 select statements inside the CTE, or that are kind of like temporary views. And then we're going to have a final select statement that joins all these different temporary views together. But the first 3 select statements are going to be creating these different results. So the very first one is going to pull out only the row with Megan Barry. So I'm going to start by saying with, and then the first CTE query I'm going to call manager because I'm pulling out Megan Barry here. And that's going to be select star, right, because I want everything. And the table I'm going to be pulling from is employees, which is the table we just created. And I'm going to do this by employee ID, and her employee ID was 2, so it's equal to 2. Okay, then I'm going to close out that temporary view, and then a comma, and then I'm going to create another temporary view. I'm going to call this subordinates 1. I can define that as, and let's see. So if we run this, this is the result set. So I'm going to be using this result set to then find the employees that work under her. So let's see, how should I do this? So I'm going to copy this first. So I don't have to type the select part. So I'm again going to select star, and I need to include the same columns because later I'm going to union these together. But I'm going to select from employees again. Notice I'm using the same table many times here, and this is what I'm talking about, a self join. I'm joining the same table with itself essentially. And here's where I'm doing that. I'm going to now join this with manager. And we're going to call that B. So manager is really a select statement that's pulling from employees. So I'm joining employees with the select statement that's pulling from employees. And that's what the self join is all about. Okay, and then for the on statement here. So here I have A. So I'm pulling now from A, which is employees. And I'm going to say that is equal to something in B. The question is now, what should I be using in here? So if I'm going to find all the employees that have Megan as their manager, then what is I need from B? Well, from B, I need the employee ID. I need this number 2 here. 1 doesn't say anything about who has Megan as their manager. So I need 2 here from the first result set. So I'm going to say employee ID here. And then if I'm just doing a select from employees like this, where should I be looking for number 2? If I look for number 2 in here, I'm going to find Megan Barry again. But if I'm looking for number 2 in here, I'm going to find these 4 employees, which is what I want. So this is going to be manager ID. So now I'm saying find all employees that have a manager ID that is equal to the employee ID from this select statement. And the employee ID from this select statement, well, we know it's 2, I guess, but if we look at the results set. So therefore I'm pulling out these. Now I'm going to repeat this query because I need to get the employees that work under these people we just pulled out. So go ahead and copy this, and then we're going to paste that into here. And we're going to again pull from the employees. So we're doing a self join to a self join. So we're joining the same table 3 times here, all the time from employees. So now let's see, we have located these 4 employees. So that is now in subordinates _1. So instead of pulling from manager here, we're going to pull from subordinates 1. So we're going to take the original data, and then we're going to join that with subordinates 1. And subordinates 1 only contain these rows. So I'm again going to be looking at these rows, and what is it I need to compare? So if I'm looking at manager ID, well, that points to Megan Barry, so that's not very useful. So what I need here is I need the employee ID from these 4 rows. So I need 6, 7, 8, and 9. So I need the employee ID from subordinates 1. So if I look here from subordinates 1, I need the employee ID. So I have B employee ID. So that still works. Then from the big table, from the employee table, where should I look for 6, 7, 8, and 9? Well, I should look for 6, 7, 8, and 9 in this column, which is the manager ID. So from employees, I need to look in the manager ID column. So I actually don't need to change anything in here, except for I need to change the join to be pointing towards the previous temporary view and not the first temporary view. So I need to change this from manager to subordinates, and then of course change the name to subordinates too. But otherwise the query is exactly the same. And this actually turns out to be important that these are identical, because this is going to become my recursive part that I just keep looping through this same exact query over and over again. And this is going to be my initial query that is static, or it just ran once I create the recursive query. But I'm not quite done here yet. So I don't need a comma at the end here, and I don't want this one. But then now I'm going to create my select statement that's going to join these 4 temporary queries together, or temporary views. So I'm going to call that from manager, and then I'm going to union that. I'm going to do another select statement, and it's going to be select star from, and then subordinates 1. Copy and paste that. And then I'm going to union that too. And because I'm doing all these unions, it's important that I have the exact same columns in all 3 temporary views. And that's going to be true later when I do recursive queries as well. I need to have the same output from this initial query as I do from the recursive portion. That's going to be recursive. Otherwise the union won't work. And then I'm going to copy this whole thing and then just change the 2. And then to make it easy to see the results, I'm going to do order by, and I'm going to order by employee ID. And by the way, how do I know what the column names are going to be? Well, it takes some column names from the very first query that's being unioned, or the first result set. So here is what defines the name of the columns. And since I'm selecting everything from employees, it's going to be those 3 column names. So then let's go ahead and run this. I should have a semicolon here at the end. I'm already seeing here I'm getting an error here on B employee ID. So let's go ahead and run and see what it tells me. It might be something else that's wrong. This is ambiguous employee IDs. So what I forgot to do was to specify where the star was coming from, or where should all the fields come from. And I don't need to do that in this one because I'm only pulling from 1 table, but here I'm pulling from 2 tables. I need to say where does that come. And then if I run it now, sure. And here's the results. And this is what we manually pulled out before. But as you can see, there's quite a bit of code in here. And importantly, if I have even more levels of data here, I'm going to have to create more of these. And if I have an unknown number of levels, or even if I know the number of levels, but if the data might be updated later, then my queries might not work. So I have to keep trying these, like I had to keep adding levels till when I add a new level, I don't get any more results. And then I know I'm done and I don't need, and my query is good. But then if I update that data and I need to run this query again, I would have to add another level again to make sure that there's no new level in the data created. And this is not a good way of maintaining code. And it's not, if I have many levels, it gets pretty complex and kind of ugly code. And that is now where the recursive query comes in. And that's what we're going to look at next.